Hello, my name is Oliver Bryant, and this is my Week 6 assignment of FTT122, Introduction to Ammunition and Basic Ballistics. With this week's assignment, you gave us a plethora of different topics to touch base on and to illustrate with household items on what they are. Starting with the first one being trajectory and sights. So the best way I can explain and illustrate it is with a baseball. If you're throwing a baseball to someone else, and if you just throw it straight at them, gravity, as soon as the ball leaves your hand, gravity is going to be pulling down on it. So overall, with it being a rather blunt object, you're not going to have the greatest aerodynamics, so you're going to have more drag. So with the drag slowing it down and gravity pulling it down, you are going to end up missing your target. So if you would throw having trajectory with your shots, throwing the ball higher, it exerts a little more energy and it slows down a little quicker, but you gain more altitude to carry it on. But then gravity will start pulling it down closer to have impact with your target. That being said, with pistol sights being closer to the barrel itself, you're going to have generally one point of impact. So with the yellow pencil being your barrel and these being your sights, this is a dramatic illustration, but this is where your sights are. When you shoot, the sights and the bullet will actually meet further downrange depending on what they're zeroed for. Same goes for rifle barrels and rifle sights. You're going to have 2 points of zero with your point of aim, so you're going to have actual trajectory of where the bullet, when it leaves the barrel, will actually go up and then arc back down at its target. So with that, you're going to have your point of aim, and the bullet will actually pass it once down here and then twice when it hits its target. So that is trajectory with sights, but it also depends on what range you have and what form of caliber of rifle you're shooting. Next topic is gyroscopic drift. So with gyroscopic drift is when the bullet is spinning so fast it actually is getting traction off the density of air. That being said, with most rifles having a clockwise twist, that would actually, if the shooter's looking at the target, will actually pull the bullet to the right. That being said, gravity is also working on the bullet at the same time, so it's pulling it a little to the right and down at the same time. So with the gyroscopic drift actually getting traction off of the density of air, like a lot of helicopters and aircraft will actually dull their props because how dense air is, and any form of particle or whatever you hit along the way, whether it be, if it's raining, water drops, that can affect anything, or humid days. Next thing is drag, and the best way I can talk about drag is the difference between a 38 special and a 223. So both being, pretty relatively high-powered rounds. The 38 special is definitely going to slow down a lot faster because with this flat face, it's causing a lot more drag. There's more surface area for the air to slow it down and for it to catch to, versus the 223 is more streamlined and it has a smaller point of impact for the air. So when it hits the air, it can pierce through and then just keep on pressing through and moving on. The next thing is the Magnus effect, and the Magnus effect is with bullets and wind, depending on if it's a right to left or left to right hand wind. So with the bullet already having bullet drift, and say the bullet's rolling, right? So the bullet's rolling clockwise, and then you have wind hitting it from the left. With its spinning, it's going to force the bullet down and push the air up. That's drastic, but that's the basic concept of what is pretty much going on. It'll actually push air up and push the bullet down. Whereas if air is coming from the right and hitting the side of the bullet, it could actually push the bullet up and push the air down. It's actually rolling up and over that air. But again, wind is rather inconsistent, and depending on where you are and where you shoot from, usually there's two very different places from where the bullet starts and where the bullet ends. So with that, air is different, air quality is different, and air density is going to be different further down range. For the next topic, you want to talk about the Coriolis and the Eötvös, if I'm pronouncing those right, effects. And the Coriolis effect is when you have, I guess this would be the best illustration, North Pole to the equator. And if you're shooting from the North Pole to the equator, I guess easier illustration is if my head was the North Pole, my hand is the equator, we're both moving and we're both keeping in line with each other, but my hand is moving technically faster than my head is spinning. So if I'm taking a shot from up here to try to hit down here with it spinning, I'm going to miss my target. I'm going to always be to the right from the north, and if I'm shooting from the south up, always be reversed to the right. Reversing where you're aiming from. And then the Eötvös effects is strongest when you're on the equator itself, and if you're shooting east to west. A best way to describe it is if you're shooting towards the west, Earth spinning on its axis, the target's technically going to be moving away from your projectile. Versus if you're shooting from the west to the east, your target is actually going to be coming towards you. In a nutshell. One of the last things you want us to talk about is vertical angles and how that plays a huge role if you're shooting uphill or downhill. And depending on the grade of altitude that you have changing with what you're shooting, you will actually have a difference in range. So I drew up a sad illustration, but long story short, because I don't have a whole lot of time, the distance of the ground and the altitude is actually more than the overall point A to point B from the highest to lowest point. So with you shooting from a low point to a high point, and then you have an altitude change, if it's Jurassic or non, you will actually have more range. So when you have that trajectory that we were talking about earlier, that will actually make your sight, your point of aim will be true, but the bullet is not going as far as you have the sight adjusted to. You're actually going to be shooting a little further, so it'll technically go over your target. You have a tendency to overshoot when you're at a higher elevation. The last thing is transonic ballistics. And transonic ballistics is pretty much when the bullet is going supersonic, and drag and gyroscopic drift and other elemental factors cause the bullet to slow down and go back to subsonic speeds. So when they transfer from supersonic to subsonic, it's pretty much like a boat leaving wakes. If a boat's flying, wakes are shooting out, but as soon as the boat slows down, the wakes will catch up to it. So once those wakes will catch back up to the bullet, it'll cause a disturbance between the bullet trying to continue to pierce air and wobble. So keeping that in mind, the bullet will continue to tumble, but if it's a more stable projectile, it'll actually correct itself to a degree and carry on. But if it is a unstable projectile, then it'll actually cause it to tumble and completely veer off and miss its target altogether. All the citing was from the SDI school book, Introduction to Ammunition Basic Ballistics. This is Oliver Bryant. Thank you.